Algebra 2, Unit 2B Study Guide. The first part of problem 1 says, where are the solutions of a quadratic located on a graph? So if we graphed a quadratic, our solutions to that quadratic would be located on the x-intercepts. We could have either 1, 2, or no solutions. Next, we're asked to draw a parabola with 1 solution, 2 solutions, and no solutions. So I'm going to start with 1 solution. That would be when my graph only touches the x-axis one time. So maybe that looks like this, where my graph only touches the x-axis once. In this case, my solution would be the point 3, 0. With 2 solutions, we would have a graph that crossed our x-axis twice. So maybe it might look like this. So this would have solutions at 0, 0 and at -4, 0. And our other option here is no solution. That would look like when our graph doesn't touch the x-axis at all. So that might look like this. My arrows are going up, so I'm never going to touch the x-axis. One thing that wouldn't be an answer, so don't copy this one down, is a graph that looks like this. This graph literally isn't touching the x-axis, but these arrows mean that they go on forever, so it eventually would touch the x-axis. So that would not be an answer. All right, in problems 2 through 6, we're solving using the square root method. We want to make sure that we simplify our square roots and not have decimals in the end. The way we do these problems is we start by getting either the x squared or the quantity squared, so like x minus 4 squared. We're going to get that part alone, and then we're going to take the square root of both sides. Don't forget that we have to put a plus minus whenever we take a square root. Our final answer is going to be x equals 1 number or potentially 2 numbers. It may be an imaginary solution or it may be a real solution. So starting with problem 2, our x squared is already alone. I'm just going to square root both sides. I get x equals, now remember, whenever you take a square root, it needs to start with plus minus. The square root of 25 is 5, and I have to put the I in there because I had a negative. Problem 3, same idea, square root both sides. On the left I get x. On the right I have plus minus, and now I need to simplify the square root of 98. So we're going to need to see what perfect square divides 98. After checking your calculator, you should find that 49 divides 98. So we have the square root of 49 times the square root of 2. The square root of 49 is 7. So our answer here is positive negative 7 square root 2. Problem 4. We need to start on this problem by getting x squared alone. So I'm going to add over the 6 and then divide by 7. Now I can take the square root of both sides and I get x equals plus minus 3. Remember, we always have a positive negative in our answer here, and the square root of 9 is 3. In problem 5, we want to make sure to get the x minus 2 squared alone to begin with, which it already is. Look at problem 6. In that problem, we're going to have to start by getting rid of the 100 and the 4 before we take the square root. But problem 5 is already set up just to take the square root of both sides. So the square root of x minus 2 squared, our square root and our square cancel out. We just get x minus 2. And the square root of 16 is a positive and a negative 4. Now we have to break this into 2 problems. One problem is going to be x minus 2 equals positive 4. The other one will be x minus 2 equals negative 4. I'm going to add 2 over on both of these. I get x equals 6 and x equals negative 2. Problem 6, I need to start by getting rid of the 100, so I'm going to add over 100 and then divide by this 4 out front. So I get x minus 4 squared equals 25. Just like problem 5, we're going to square root both sides. We get x minus 2 equals a positive and a negative 5. We're going to break it into two problems. X minus 2 equals 5. I'm sorry, not minus 2. I was looking at the previous problem here. It should be x minus 4. So whatever's inside of here stays the same. And then we have x minus 4 equals negative 5. If I add over 4 on both sides, I get x equals 9 and negative 1. For problems 7 through 10, we're going to simplify these expressions using imaginary numbers. And recall that anytime we have an I squared, we're going to replace that with a negative 1. So you'll see that's kind of what I'll do at the end of some of these problems. So for this first problem, we can either use box method or FOIL. Either one works. I'm going to use FOIL. So whenever I multiply each of the terms in the first parentheses by each of the terms in the second parentheses, I get this line. And now what I'm going to do is I'm going to combine like terms. And I'm replacing my I squared with negative 1. 6 times negative 1 is negative 6. And then I can combine those like terms of 8 and negative 6. For the next problem, we're going to start by distributing this negative into just the parentheses of 2 plus 3i. And then combine like terms. For the last problem, I'm going to distribute the 2i, replace my I squared with negative 1, and then combine like terms. And then I did rewrite this last one. Instead of having it 8i minus 2, I wrote it in the form a plus bi, since that's how we write complex numbers. So I put the real part first, which is negative 2, and the imaginary part second, which is 8i. For problem 10, we're going to simplify each of these radicals, and we're going to need to make sure that we show our work. So some of us have calculators that will just do this for us, but we won't get credit on the test if we don't show work. So first of all, we need to have our list of perfect squares in front of us. This would be a good list to write down on your test. It's just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So you can get all those pretty quickly if you just square each number in your calculator. And then we're going to start with square root of 8. So the first thing I want to do is I want to figure out where 8 lies in this list, which is right here between 4 and 9. So I'm going to look to the left. My only number that I really want to care about is 4, and it does divide 8. So I know I can rewrite this as square root 4 times square root 2. The reason being because 4 times 2 is 8. The square root of 4 is 2, and the square root 2 just stays the same. Next, for square root 75, same idea. We're going to figure out where in the list it falls, and then we're going to see what divides it, what number to the left divides it. So 64 doesn't divide 75, 49 doesn't, 36 doesn't, but 25 does. So now I know I can write that as the square root of 25 times the square root of 3. 25 times 3 is equal to 75. And I can simplify this by taking the square root of 25, which is 5, and leaving square root 3 as it is. Same idea for 90. Figure out where 90 falls in our list, and then see what number to the left divides 90. 81 doesn't, 64 doesn't, 49 doesn't, all the way down to 9. 9 divides 90. So I'm going to rewrite this as square root 9 times square root 10. 9 times 10 is 90. And then simplify it to be 3 square root 10. An important note to make here, we are not using plus minuses in front of each of these because all we're doing is simplifying expressions. We're not solving equations in this problem. Next, we're going to work on solving quadratics by factoring. So remember, the first thing we're going to do is set our equations equal to 0, which these two already are, and then we're going to look to pull out GCFs if possible. Since we're solving, our final answers will be x equals a number. It could be 1, 2, or no solutions. So for this first problem, I notice that there's no greatest common factor. There's no number that divides 1, 15, and negative 16. Those are my A, B, and C values. So now I'm going to set up my x. I have A times C in the top and B in the bottom. So negative 16 up top, 15 in the bottom. I want to figure out two numbers that multiply to negative 16 and add to 15. Make sure that you double check these two numbers on the test. So just check them in your calculator, make sure they multiply to what you want and add to what you want, and be careful with signs. So now I'm going to go back to my problem, and I'm going to replace the middle term, 15x, with my 16 and my negative 1. I'm going to flip them. I want my negative 1 to be with my x squared and my 16 to be with the other 16. So I'm going to write x squared minus 1x plus 16x minus 16 equals 0. Now I draw a line down the middle, and I factor by grouping. Pull out a GCF, pull out a GCF. Remember, those two parentheses need to be the same, so they both say x minus 1 in them, so that's good. My factored form is going to be x plus 16 times x minus 1. And now to solve it, I'm going to set both these factors equal to 0 and get my solutions. For the next one, I again notice that I don't have a GCF. No number divides into 3, 2, and negative 8. So I'm going to set up my x, AC on the top, and B on the bottom. So this time for my AC, I have 3 times negative 8, which is negative 24. Again, double check, make sure that your two factors that you find, in this case 6 and negative 4, multiply to what you want and add to what you want. So now we're going to replace the middle term. I'm going to pair the 6 up with my 3x squared, and the 4 I'm going to pair up with the negative 8 because they have good common factors. Draw a line down the middle and factor by grouping. My factored form is 3x minus 4 times x plus 2, and I'm going to set both those equal to 0 and solve.